Now we will begin speaking about the gas laws. Boyle's law. Robert Boyle investigated the relationship between the pressure and volume on a gas, holding the temperature constant. He found that pressure and volume are inversely related. You will recall this means that as one variable goes up, the other one must go down. So in other words, as pressure increases, volume must decrease, and vice versa. Again, temperature must remain constant to use Boyle's law. The equation is P1 V1 equals P2 V2. So pressure and volume for the initial conditions are P1 V1, and P2 V2 are the new pressure and volume, or the changed conditions. This works provided you know the initial pressure and volume of the gas and you are given one of the final pieces of information. Now remember, all of these gas laws will have an initial set of conditions, and then we will change a variable which will result in two new conditions. Again, you will be given the initial pressure and volume and one of the final conditions and solve for the remaining unknown condition. Or we could ask you to work backwards, giving you the two new conditions, one of the starting conditions, and solve for the unknown. Next we have Charles' law. Jacques Charles investigated the relationship of temperature and volume in a gas. He found that the volume of a gas and the Kelvin temperature of a gas are directly related. You can already guess that if these are directly related, we will be using division in our equation. Charles' law is volume initial divided by temperature initial is equal to the new volume divided by the new temperature. Remember, temperature must be stated in Kelvin. I cannot emphasize this enough. It must be stated in Kelvin. Next we have Gay-Lussac's law. Since temperature and volume are related, it would make sense that temperature and pressure are related. The equation for this will resemble Charles' law, which means you will know that they are directly related, which means we will also be, you guessed it, dividing. So the initial pressure divided by the initial temperature is equal to the new pressure divided by the new temperature. Again, these are directly related, and we're dividing those variables. I cannot emphasize this enough. Again, temperature must be in Kelvin. Finally, we have the combined gas law. This law takes the ideas of the scientist and melds them into one law. So we'll combine pressure, volume, and temperature for the initial conditions, which will be equal to the new pressure, the new volume, and the new temperature. Now, hopefully this seems like common sense, and if you remember this law, the others are superfluous, meaning if you memorize this law, you can find the others, and I will show you how that works. If we take our combined gas law, which is pressure initial, volume initial, divided by temperature initial, equals new pressure, new volume, and new temperature, and we hold temperature constant, meaning if temperature is not changing, we can kind of ignore it. You'll notice we now have P1 V1 equals P2 V2. Whose law was this? That's right, Hopefully you said Boyle's. Inversely related, and we are multiplying these variables. Keep in mind, if we were to graph this and you were to look at an inverse relationship, you would see something with a slope like this or a slope like this. Now let's look at the combined gas law again and hold a different variable, this time pressure constant. So here's our combined gas law. If we're going to hold pressure constant, in other words, cross it out, or you could erase it, you'll notice we have V1 over T1 equals V2 over T2. This would be Charles' law. And we know that Charles' law is directly related which if we were to graph this law, we would see a graph such as this. Now, the combined gas law holding volume constant. So yes, as you figured out, we'll write out our combined gas law one more time. If volume's constant, we can ignore it or cross it out. And we have P1 over T1 equals P2 over T2, otherwise known as Gay-Lussac's law. This one is also directly related. So again, if we were to graph this, you would see slopes or trends such as I just drew out.